on this computer. Okay, let's start. Hello everyone, I'm your friend Sanjay again in this NSS series. So today's our second training and it's about the NSS Advanced. So in previous training, we learned about the NSS Basic. In this training, we're gonna learn more about the NSS and that's why the name NSS Advanced. Here is the agenda. We're gonna understand more about the NSS. We're gonna understand the NSS architecture, connection flow, how to take packet capture on NSS, what are the SNMET interface commands, right? We can use and what's the purpose of these commands and where the NSS, store its logs. So let's start with the NSS Advanced. So the underlying operating system NSS runs on, that's a free BSD operating system. FreeBSD is an open source Linux-like operating system, right? And when you boot your NSS, you would see or you would get the very first screen of that FreeBSD. You can see in the screenshot as well, right? So what Zscaler has done, Zscaler has customized that FreeBSD operating system, created its own SNMET stack on top of it, and then they call it Zscaler operating system. Okay. The version of the latest version of Zscaler operating system, which NSS runs on, that's the NSS ZSOS 24. Now you might have already deployed NSS from our basic training. So how do you check that what's the version of NSS OS you running on? So for that purpose, you can use a command uname -a. And this command will give you the details like below we can see, right? In these details, we can see it's a Zscaler OS 24 release P11, right? That's the date. And we can also see the free BSD version as well. So this command tell us about, more about the operating system. Okay, now we know, right, from this from our basic training that there are two interfaces, SNMET and the TCP stack, the management interface. So the SNMET, the service interface is the one which follows that SNMET stack, and the service interface follows the TCP stack. Okay, since the service interface follows the follows the SNMET stack, we need to have we need to run commands, right, in a certain predefined format, like on any other operating Linux or Unix operating system. If you want to check something, right, let's say we want to check IP details, right? So what we use a if config command, and that's true for the management interface because the management interface follows the TCP stack. So in the NSS also, if you run if config, you will get the details of or the IP details of your management interface. If you want to check the IP details of a SNMET stack service interface, which is EM1, you need to run a command in a predefined format. So it always start with /sc/bin smmgr -ys is a switch, and SNMET is the stack we're calling, and then equals to the command we want to run. So we can run if config, we can run ping, we can run telnet. So that's the how, that is the way, right? You would run commands on the SNMET stack. Now, this NSS also have a configuration file which we call sc.conf. This sc.conf stores so many details about the NSS. It stores the details that which port it's using to connect to the SMCA or SMSM. It also contain the path or certificate, the public private key certificate for SMCA, And it also has the the service IP mapping details, and of course the service IP details as well. So let's see, right, how we how let's just open our NSS and let's just check these command one by one. The first, let me show you that how you can check. So this is the NSS. I already logged in. Let me show you first the NSS version I'm running on. For that purpose, I have to use the command uname -a, right? That's A is a switch. And you can see it's a Zscaler OS, release 24p11, right? Uh, and that's the version. And we also see the FreeBSD version here. Now, the second thing that I want to check, the IP configuration detail of this NSS, right? So one command, we already know that sudo NSS, right? Dump config. So that's the command we know from our basic training, right? And that's where we also get the DNS configuration, the default gateway, and the service and management interface configuration as well. Now, the another command, if you want to check the IP configuration detail, right? If you can use, you can use ifconfig, and that will tell you the details about the management interface IP details. So you can see EM0 is the management interface. It has the IP address 10.0.0.25, right? EM1 is the service interface, but if you see, it's active and running, but we don't have IP address details here. Okay, to check this IP address details, we need to run a command, through the service interface itself. And for that purpose, we need to use the command in predefined format, and that's how we're gonna use it. So we're gonna use /sc/bin/smmgr, and then you're gonna see the details of the service interface. You can see GSN, GS0 is the service interface, and GS0 equals to EM0, right? And you can see the IP we configured 10.0.0.26 on our service interface, and the send receive bytes as well. Now, the SC configuration file which we have, which contains most of the configuration details for the NSS, let's just open that file as well. To open that file, I'll have to do cat/sc/conf, and that's the folder where it is, right? And the name is sc.conf. Now, once we open this sc.conf file, what we get the port details, right? This is SMCA port 9422 it's using. The SMSM port is 9431. Okay. Now there are other details as well, like the certificate and the private key and the service interface we have, and the tap interface it's listening on. We also have other details regarding the Kafka, but that's not that will not cover this in this training. So this is how, or this much details you can get from the service interface. Now, from our basic training, right, we learned that we don't need inbound rule to create for our on our firewall or any proxy, right, to allow NSS to work. However, we do need to create outbound rules so that Zscaler NSS can communicate to the Zscaler cloud, or maybe to the SIM, or to the to the DNS name server. For that purpose, we need to allow the service and management interface, to connect to the 443 for the, from the service and management IP address to the Zscaler Hub IP. For the remote support purpose, we need to allow 12002 port TCP protocol, right? And for the DNS resolution, we need to allow the local name server, or maybe if you have configured, a public name server, then that too on port 53. And of course, you need to allow the NTP IP as well, the local, if you have configured, customize it. Otherwise, the global NTP server IP address or host name on port 123 UDP protocol, right? and the NSS service IP address, which connecting to your SIM solution on port, on port you have configured on feeds protocol TCP. Now, how do you get this Zscaler hub IP addresses, right? Or maybe a remote support IP address? That's something you'll get it from the Zscaler portal. So if you go to the config.zscaler.com, right? And once you go there, you need to select the cloud you are on, right? So in my case, my tenant is provisioned in Zscaler 2.net, right? Now, from there, you check the firewall configuration requirement, right? And you go through this configuration requirement. That's what you have to review. And regarding that hub IP addresses, you click on from the left, there is a hub IP address details section, right? So this is the hub IP details section. You need to check or allow these all IP addresses for NSS to work. Okay. All right. Now, let's talk about the NSS architecture. Okay. So if you see the picture, right, which is on top, we already seen this picture in our basic training, and we understand the flow of traffic, right? So the traffic comes from your headquarter to the Zscaler, or maybe from remote user to Zscaler, right? Zscaler process that traffic, right, and forwards to the internet, to the destination. When Zscaler process that traffic, it generates some logs, right? So let's say you're accessing abc.com, it has generated logs for that. These logs are stored in the nanolog cluster, and then it forwards these logs to your NSS, right? And then your NSS forward these logs to the SIM solution. That's the flow we understand already from our basic training. But now, if you focus on the picture just below where we have highlighted the NSS, right? So NSS has two interfaces. One is called the managed interface, other one is called the service interface. So the management interface is used mainly for the management purpose, right? To SSH, for the software update, or if there is any patch update, right? That's what the management interface is used for. And the service interface is the one which connects to the SIM, which connects to the SMCA, which connects to the an analog cluster. Now these connections, the NSS makes, right? These three connections, but it's not like NSS randomly make these connections, right? There is a flow for these connections. The first, once you boot your NSS will always connect to the SMCA. Okay. Once it's connected, authenticated, authorized, right, to the Zscaler cloud, and we know that happens based on the certificate we have installed in the NSS, it will download the feed configuration, right? Once that feed configuration is available to the NSS, it will check for the feed, SIM IP and port details, and then it'll create a connections to SIM solution based on the port and IP you configured. Once that up, NSS will connect to the nanolog cluster. And once we have these all three connections up and running, we will start seeing logs, right? And NSS would start, nanolog cluster would start forwarding logs to NSS, and again, NSS to your SIM solution, right? So these all connection needs to be up and running in order to, to get logs. Now, we know that these connections are there, right? And it formed these connections that we talk about, and the flow as well. But there are three important ports which we have seen already, the 9422 and 9431. So the 9422 is the port which NSS used to connect, to the SMCA, and the 9431 is the port which NSS used to connect to the SMSM, the analog cluster server. And SIM port, which we already know, which whatever port we have configured on our NSS feed, right? Now, from our basic training, right, we have checked, we ran the command sudo NSS troubleshoot NSS, right, netstat, and we grabbed for the TCP. And what we saw the connections to these three. We saw these three connections, right? So let me run that command once again. Sudo NSS troubleshoot and netstat to see the connection table of NSS, right? Let's just grab it for TCP. So what we can see, this NSS has created three connections, and these three connections are to so this first one is to the SMCA, right? The second one, which is to the private IP.18, that's to our SIM server, and the third one is to the SMSM, right? Now we already know that there is a flow for these connections, right, and how these connections are established. But you may be wondering, the port you see, that's 443, not the 9422 or 9431, right? To get these port, or if you want to really check, right, whether these connections are on port, 9422 or 9431, we need to run the command. And that the command we need to run is this, which is /se/bin/smmgr -s ccb equals to netstat. So that's the command will tell us the details about these connections. So let me run that command quickly. Okay, so I bring our NSS up and let me just copy paste. Okay, now if you see in this, okay, we have connection, the same connection what we see above, right? Same IP. But if you see the port details, you're getting the port now. It's 9422 and 9431. The outer protocol is again still the 443 and the 514 for the SIM. But the inner protocol, you can see that NSS connects to these over these ports, right? Okay. Now, once these connections are up and running, right, we know that NSS is okay. The connections are successful. One thing to know, right, when these connections are up, you would start getting logs, right, and your NSS would show in healthy status. But one important thing to remember here, that NSS would start showing you as a healthy status as soon as it can connect to the SMCA, right? And it's authenticated successfully. What I mean by that is this. So we have these three connections, right? The first one is to SMCA, then to the SIM, and then to the SMSM. As soon as there is a first connection done, right? It's connected to the uh, to the uh, to the SMCA on port 9422, and it's authenticated. The Zscaler cloud will start showing the status for NSS as a healthy. So the healthy means connection to SMCA is okay. It doesn't mean that you start receiving logs. You may not getting logs, right? The connection to SIM may not be okay. Okay, so you need to check all these connections to understand if the logs are there or not, right? Now the next thing is to capture, right? How to capture on NSS, since we know there are two interfaces. One follows the SNMET stack, one follows the TCP stack. So the TCP stack, the management interface captures is the similar way what we do on any other Linux, right? We simply use a TCP dump, and we define an interface. Hyphen is basically do not do any DNS resolution, and we can simply capture it. But if you want to capture on a service interface which follows the SNMET stack, then you need to use the predefined command, and you have to use the syntax. So for that purpose, we need to use this /sc/bin tcp dump.sh. That's a script it would run. I mean, in the back end, right, it actually calling that TCP dump, process, but that's how it is created. Now, -I and tap is the interface, and you can think of tap1 equals to AM1, okay? And then you store, -W to where you want to store these pcaps, okay? Now, you may wondering that, why I'm using tap1? To see that why tap1, why not tap2, tap3, you can check if config. If you see only one tap interface, you can use it if it's tap1, tap2, tap3. Ideally, right, and usually it's tap1, or we have already seen in the sc.conf command, right? We had that tap1 interface detail. So there are two places how you get the tap interface details. Okay. Now let's run these commands, right? Let's just capture. Okay. So now first what I'll do, I'll capture on the management interface. Okay. So I'll run the exact command I have in our slides. And that command is sudo tcp dump -n -I. EM0 means I'm capturing on a management interface, and -W, this is the location I'm storing these captures to. I started this capture, and it's, I can see that, it's listening on this EM0 interface, and this is the size of the capture. Let's run it for a few more time, right? Maybe 4-5 second, and let's just stop it. But this is just for the demo purpose. And what we can see, as soon as we stopped this capture, we can see 17 packets are captured. So let's see what we have in these 17 captures. So I'll use TCP dump -R, and then I'll use this path where we have that capture stored. Now, based on this, what I can see, this is our management interface, and it's trying to connect to these, this IP. And if you check the port, right, this is the port for the remote purposes, right? So that's where it's connecting to, and the SSH connection as well, right? And there is some ARP request as well. So that's how you can collect captures on the management interface. Now, to capture on a service interface, and before that, let's just check which tap interface we need to use. So if you do if config, right, you will get the details of the tap interface. So it's a tap1, which is active and running. So if you have multiple tap interface, the first thing you need to check is maybe, to see what's the tap interface which is active and running. Okay. Now let us run the captures on the service interface. I'll use the same command which we have in the slides, /sc/bin smtcb dump.sh. That's the same script. -I is a tap, that interface I'm calling. -n -W we have to store, right? So let me run it. Now, as soon as I started this, this command, I can see it's listening on tap interface. Again, that basic details we get, right? Okay, and let me stop it now. I think it may have captured. Okay, so we can see now it has captured 69 packets. Okay, so let me do TCP dump -R, and let me just open this service interface captures. Okay, now in this service interface captures, we can see that our service interface, which is 226, connecting to the Zscaler cloud, right? Yeah. Okay. Now next is the SNMET commands, right? So there are so many SNMET commands we can use for the various purposes. I'll walk you through these commands, and I'll let you know the purpose of these commands as well at the same time. So let's start with the first command which we have, and that is smctl.sh status. So what this command is basically, this command tells you what is the status of NSS. Are the all services of NSS are running or not? So if you can see, as soon as I ran this status command, I can see that smstat is running, smcds is running, smmon is running. If any of these services are not running, that means the NSS is not functioning, right? You may, at time, you may have to stop it, and start it, right? So if I start, if it's not running, I can run start and it'll check the process and it'll try to start these processes, right? The second command is that if we do ping, right, 8.8.8.8, that ping is from the management interface. It's following the TCP stack. Now, we have to run the SNMET stack. So what we do, we use the same syntax and we define the command we want to use. In our case, we're doing the ping, right? And we get the similar output what we see from the our TCP stack. At time, you may need to check, right, what is the ARP table from the service interface. So you can see we have ARP entry on our server interface for the .18, which is the SIM IP address, right? And this is the default gateway for us. And it's telling us this is the ZS0 interface, right? Also, next command we have is to check the route from the service interface. So for that purpose, the syntax is similar, right? Nothing changes there. Only the thing changing here is the, what we want. Do we want to check ARP table or we want to check route? It's not like we can do everything. There are some predefined command only what we can run. So when we run that route command, it's similar what we get, the route on the Linux, right? So it has the destination, the gateway IP addresses, right? MTU details, and the expiry and the use as well. So it's the same thing what we get, right? Now, okay, so this command which we already know that the connections to our SIM and the SMSM and the SMCA, and we already know that how to check, but this is very basic detail, right? It's not telling you more about these connections. If you want to know more about these connections, we can use the same smnet command, but using a different switches, right? And the switch we will use instead of smnet, we're going to use the switch PCB, right? And that PCB is the switch we use, and the netstat is the table. This would give us more detail about these connections. So if you can see, this is the index, right? It also telling us about the uh, about the let me tell you, it's telling about the MSS configured, right? It's telling us about the local IP and this destination IP addresses, the the bandwidth, the receive window, and the send window as well. How many data received and how many data sent, right? So this is very helpful in case of troubleshooting, right? You get more details here. Okay. The next very important command, you may be able to do NS lookup too, right? Let's say if maybe you're able to ping shape skills, right? SKI skills.n, right? I think you can, oh, I think it's misspelled. Okay. So I can ping shapeskills.in, right? And this is from the, again, from the management interface. What if I want to check the DNS connectivity or a DNS resolution or TCP connectivity from the server interface? So in that purpose, I'll be using the same syntax SMMGR. I'll be giving a host name for which I want to test and Y as the DNS. You can see the first it has done that DNS resolution, right? And that's it's established, right? Similar way, if you want to check the port reachability, TCP connection status, whether it's happening or not, you would use the same command, but the only thing changes there, maybe you can call the protocol port number, where on which destination listening on, and the connect type is the TCP. And there you can see it has done the DNS resolution first, and then it establishes a TCP connection, and it says it got established. Mostly, right, and most of the time this you need to check for your SIM solution. You may have some firewall or something which may blocking these connections. So for that purpose, you would use the internal, you will use host, and you can use your SIM IP address and the port and the protocol. Okay. Now, the next command we have in this list is the feed details, right? So how do you understand, how do you get the all the feed this NSS downloaded, right? You may have configured multiple feeds, right? So for that purpose, we run a command get sm info equals to NSS underscore feed underscore info underscore all. What this gives us the feed ID, the SIM IP and port configured, right? The time zone configured in that feed, the send receive buffers, right? It also tells the name of that feed. Either it's a web or firewall feed. So it's a web feed, it shows one. It tells us the the output format. Okay, you can see in the raw format. It also shows us if there are any filter or encoded character configured. So you can see there are no, there is nothing configured in our portal, so we're not seeing anything here. That's what you get, right, through this feed details. If there are more feeds configured to this NSS server, you would get all these outputs, right, all the details. Okay, now the next in this list and in this training is to, I think so we have covered all these what we have mentioned. Now next is that the NSS logs, right? So NSS stored logs of itself, right? Maybe it's having issues with the upgrade, maybe it has issues starting services, or maybe the NSS update or patch update or anything is failing, the SSH is failing, right? Or the installation of sub services are failing. For that purpose, NSS store logs, and the logs are mainly stored in the /sc/log folder in the file for upgrade, right? It's auto upgrade.log. For installation, it's install.log file, and for the Zscaler services related, it's a zscaler.log file. We do have a message related file in the /bash/log folder, and that's called message.log. We can Let me just quickly show you the path and where these these log files are. We'll not go into detail for in the detail that what these logs contain and how to review and when to check it. We will have another training for it, but let me just quickly open auto upgrade log, right, to show you that how what it what it has, right? So /sc/log, and then I'll do auto upgrade, right? And deadlock. So if I open this file, you can see, all right, you can see, right? So it started the NSS upgrade, right? Extracting, extracting that build, and that's successful, and the service is restarted there as well. So if there is any issues with that, right, with extraction or installation, you would get these all details in the auto upgrade log, right? Okay. Now, what next? Okay. For any questions you have, you can you can ask me in our YouTube comment section. Either I or anyone who who have watched the video and have know the answer can answer these questions. All right. So yeah, thank you very much for your time. See you in our next training. Bye.